Hello, dear students. How are you all? I hope you are all doing good and studying really very hard. So today I come up with this set of 5 questions in electrostatics on the topic Coulombs law, and these questions are really amazing because I have seen, although students have a good concept, a good command over the concept, and also they understand theory very well, but then also these are few questions which students generally ask, and no student actually have clue that how to solve it, and only few students could solve it on their own. So these questions are must to see, and you would also gain something from these questions. Okay, students, so let's hope you will find it useful. Okay, so question number 1. This question is not uh, it's not like you have not seen this question before, but let me tell you, out of 100 students, at least 90 students ask this question, and they make mistake in these questions. And let me clear it once and for all. And these are the questions which are asked in immense number. So okay, let's solve this. Now question is, where should a charge q1 be placed so that net force on it is 0? Now I have actually taken two question. I took two question actually, so that I can explain you the minute difference, and also you would not be confused in any situation after solving these two questions. Okay, students. So in the first case, uh, we have taken two positive point charge, and we have to place a charge q1 somewhere between A and B, or somewhere on the line joining A and B, such that this charge q1 remains at equilibrium. That means net force on it 0. The question can be asked in such a way that uh, find the value of q1 also, and where it should be placed on the line joining the this point charge A and B, such that system remains in equilibrium. So the solution is same for both the question. I will explain you first this question, such that net force on charge q1 is 0 in both the cases, and I will also tell you the short trick. There is a formula, and you can solve this question very fast. Okay, fine. After that I will tell the second part also, that system, how we will solve for the condition that system remains in equilibrium. Okay, students. So here, this charge q1 and this charge q2 for q are at distance r from each other, and suppose a charge q1 is placed at a distance x. Now for equilibrium, net force should be 0. So that means here we can say that on charge q1, this charge a is, let me use another pen, this one. So charge q1 is forcing it this side, f1, suppose f1 force or fa force, and the charge on the b is forcing it on left side. Let's say it is fb. Now for net force to be 0, obviously fa is equal to fb, and what you will do, you will simply solve it k q1 by x square, because the distance between q and q1 is x, and force fb, that is k q1 into 4q, divided by this distance must be r minus x. I didn't write, but yes, it is r minus x. So after solving, you will see that you will get r is equal to 3x. Here we got x is equal to r by 3, so we got a positive answer. Let me tell you one more thing where you get confused. In this question, when we are solving this step, we must get this answer: r minus x is equal to plus minus 2x. So we could have taken plus or minus both. So if we take plus sign, we will get r minus x is equal to 2x and x is equal to r by 3. Fine, this is the answer. And by taking minus sign, we will get r minus x is equal to minus 2x, and this is x is equal to minus r. X is equal to minus r. So this result is neglected here because minus r at the location minus r, that means minus r is on the left side. Minus r on is on the left side. So here, if you place a charge, if we place a positive charge, then we will see this both uh, this and both charge b and a will force it on the left. And if this q1 is suppose negative charge, then this both charge a and b will force, will attract this charge q1 towards right. So in both the case, net force is not going to be zero. That's why this choice is neglected. So yes, when you solve, you have to consider this plus and minus sign, and then after that you have to uh, eliminate one answer. So this is what is not shown here. Fine. So here we have not considered this solution. Okay, so answer is this. This is okay. Now in this particular question, now students really get confused because maybe they didn't listen to the question or the concept in class properly, or after having good command over the concept also, they uh, okay, they do it wrong way. So here it is very simple question. Now we want, suppose we have placed a charge q1 resistance x on the left. So firstly, why we didn't choose this position? Because if we had chosen this position for q1, then now q1, this charge q is positive and this is also positive, so force on q1 will be on this right, fa will be towards right. Now what force this charge on b will apply? Now this is negative charge, and negative charge will attract positive charge, so net force will also, that fb will also be towards right only. So net force is not going to be zero in any position between a and b. And also remember that here it could be this position also, but let me tell you that you will never get a equilibrium position near the charge of bigger magnitude. So first always start with the side of charge with lower magnitude. Okay, so after that it is really easy. Now for net force to be zero, here also I will write that charge force fa is here, and force due to fb, force due to b will be towards right, and net force to be zero. Obviously we will solve it again and you will get the answer, x is equal to r by 2. Here also we must have got this step, and we have eliminated one of the solution by similar reasoning. Okay, now this is okay, you must have solved this problem, and okay, you have learned. Now this question can be solved by using just one formula, and this is here. Suppose a charge q1 is placed at this point and charge q2 is placed at this point at a distance r from each other. And now where should the charge, suppose small q is placed such that it remains in equilibrium? So we have very beautiful and very simple formula, is that is this. Uh, Now x is equal to root q1 into r upon root q2 plus minus root q1. Here you must remember that in the numerator you will get that charge from where you are finding distance. Like we are finding distance x from charge q1, right? So you have to put charge q1 in the numerator. That's it. And in the denominator, just remember that because we are getting plus and minus both, that's why. So put charge of bigger magnitude here and just put negative, just put the magnitude, not the sign, because you know that in an under root you cannot put negative value. So here this is the formula. Now you just remember one thing, that just put positive sign when charges q1 q2 are of same sign, and put negative sign if they are opposite sign. And let's check it. So here we are finding distance from uh, small q, means charges of low magnitude. So I will write here x is equal to root q. You have to put charge, that value of charge from where you are calculating distance. So root q upon under root of charge of bigger magnitude, right? Charge of bigger magnitude, that is root 4q. Okay, 4q. So I will get 2 root q minus, sorry, plus root q. You will use plus sign when uh, both the charges, both the given charges are of same polarity. So yes, here you are getting r by 3. It is very simple. And in this case you will use negative sign, obviously. So now again we are we have taken x from the charge of lower magnitude, so q, I will write that, upon charge of bigger magnitude, it is 9q minus q, and here we will get the answer. So if we put minus sign, let's see what we are getting. Now root q upon 2 times of root q minus root q, I think we have got the same answer, r by 2. So I think this question have become now become very easy now. Okay, so this is one question, and now I think students, you will not get confused in this question. You know the basic details also, and also you know the formula. So okay students, all the best with this question next time, this type of question. And yes, this can be asked in exam. Now this is really amazing question. uh, Now what is question? There are two charges, there are two masses, and it is they are having charges also, q1 m1 q2 m2 and theta 1 theta 2. Now you are asked to compare angle theta 1 theta 2 in this following cases. Suppose q1 and q2 are same and m1 and m2 are same, then what? And similarly four different cases are there. So if q1 and q2 are same and n1 and n2 are both same, like both are identical particles, and obviously length of the strings are same, then consider this diagram. Suppose masses are same, okay, and q1 q2 are same, so we know that fe, the force of repulsion between these two objects, are k q1 q2 upon whatever distance is there, r square, right? So now we noted by Newton's third law, this force fe is acting on both the charges. Doesn't matter q1 q2 is same or different, but both q1 q2 and is experiencing charge force of fe, same magnitude, right? And along the line joining both the particle. Now as both particle also have same mass, so we have one more component, vertical component is mg, it is same. And now it's time for tension. So we know that tension will be along string. Now we know that, now this is really important, you have to listen it carefully. We are seeing that there are three forces: tension, fe and mg, and the net force is zero, right? Net force is zero. So we can say that tension is balancing the resultant of, the tension force is balancing the resultant of Fe and Mg, and this is, and actually it is opposite. So this tension vector is opposite to the resultant of Fe and Mg. So let me draw this here. Okay, fine. So this is the resultant, and tension is actually balancing this. This is the F resultant. Yeah, let me write it properly. Hmm, this is Fe vector plus Mg vector. Now, now as tension and this resultant is opposite, then this must be theta, and we can write tan theta is equal to Fe by Mg. This is really simple. Now the same thing, let's say this is theta 1, you will write tan theta 1 is equal to Fe by mg, right? And if this is m1, then you would have written m1g, and for right side you would write tan theta is equal to Fe upon m2g if suppose masses are different. But here masses are same. Here masses are same. So no doubt, if masses are same, if m1 is equal to m2, then theta 1 is equal to theta 2, right? So if m1 is equal to m2, then theta 1 is equal to theta 2. So answer will be theta 1 is equal to theta 2. Now in second part, q1 is not equal to q2. Now here we have solved the example which we took here. In order to find solution, we took different charges, and we seen that different charges does not create any problem here, because even the charges, magnitude of charges are different. Then also by Newton's third law, the electrostatic force of repulsion acting between both the charges are of same magnitude. So it doesn't matter. Q1 is not going to make any difference. So even if Q1 is not equal to Q2, the angles are going to remain same. Now M1 and M2 are same, so obviously we are seeing that this theta angles are depending only on this m1 and m2. Now you can fairly see here that if mass increases, then theta decreases. Yes, so this is going to happen. In the next part, they kept q1 is equal to q2, but m1 greater than m2. Now they did it. Now if m1 is greater than m2, then you know that if mass increases, then angle decreases. So in case 3, it happens theta 1 decreases. Now as m1 is greater than m2, then obviously this theta 1 will be lesser. So I will write theta 1 is less than theta 2. And in the last case, it doesn't matter if q1 is greater than q2 or if it is less than q2. If m1 is greater than m2, then obviously the result will remain same, that is theta 1 is less than theta 2. So this is very cool example. There is one more method by which you can solve this type of question by using torque method. Just take torque on this system about O. Now if both this Fe and Fe are going to be same, and the torque of this force, electrostatic force, is going to cancel out each other. Like these are like force couple, and the force couple in between, the distance between the line of action is 0. So torque of Fe is 0 about this point, and only the torque of mg remains. Now if both mg are same, then torque will be 0. If suppose m1g is greater than m2g, then obviously students, this will try to tilt like this, and then theta 1 will be less than theta 2, and this is our solution. I think this is what we uh, found out. So the torque method is also really uh, good. Now this question is, like I'm telling you, almost 100% of students ask these questions, and even after telling them the correct method, they do mistake again and again, because there is some differentiation involved in it, but that differentiation is not really that difficult. Only that students who are preparing for NEET medical exams, they really, they are reluctant to solve any question which involves differentiation. But believe me students, here differentiation is really easy, and just see how to solve this question. Now in this question, actually, there are two charges, q1 and q2. This is q1 and this is q2, and they are placed at a distance r from each other. Now we only know that q1 plus q2 is equal to q. That means we have to divide q1 q2. Fine, okay. Now they are as there will be maximum repulsion in between when. So we know that force of repulsion will be k q1 into q upon r square. Now let's write this as a small q, so this will become capital Q minus this. So I will write this k into q1 is, now q1 has become small q, and this is capital Q minus small q, divide by r square, that is constant. So we are seeing that f is depending on f is a function of, right? F is k by r square and capital Q small q and q square. So we are seeing that simply f is the function of small q, and you must know only one thing, that for f to be maximum, you need to do df by dq is equal to 0. It is same as like y is a function of x. For y to be maximum, for y to be maximum, you need to do dy by dx is equal to 0. That's it. Just differentiate with respect to x, or differentiate it with respect to the variable, and just equate it to 0. So if you solve, now you will get the answer. Now if you differentiate, this k by r square is constant, so I will just put it aside, and now I will write, now if you will differentiate, that capital Q is a constant. Now differentiation of q small q is 1 minus, you must remember that this is q square, like y is equal to x square. What you will get by differentiation? 2x. So you will get 2q, that is 0. So you must remember that q by 2. So if q is q by 2, that means capital Q1 is q by 2. Obviously q2 is equal to q by 2. So you must remember this solution, that force of repulsion will be maximum when both the charges are divided equally. Both the charges have equal magnitude. Now, okay, students. Now this question is really, I am telling you, 100% of students ask this question. Even the topper, like topper is the student who is getting good marks is not some coming from Mars, but yes, even the students who who are really who are doing really good and have really good command, they also ask this question, and so that's why this question is in my list. Okay, students, let's solve this question. This is not really that difficult question, but because it involves the concept of fluid mechanics also, this become really difficult question. But now, for once and for all, I'm explaining you, you must now not having any doubt left in this question. Okay, students. So we have already seen one such situation, and we know that in this case, normally tan theta is equal to Fe by mg. We get this answer, right? And I will, if I open that Fe, then we will get 1 by 4 pi epsilon naught, right? Okay. When in vacuum, we know that we will get this answer. In vacuum, we will get this answer. Here, one more information you must know. In question, it is given that in vacuum, suppose this angle is theta. In vacuum, this angle is theta. This situation is given in vacuum. Fine. I have already written here. Now, if this system is submerged in a liquid having density rho, if this whole situation is submerged in a liquid of density rho, let me just uh, all this, because I have to do some calculation also. Like this is good. Submerged in a liquid having density rho, and we don't know the permittivity which is being asked. So let's say permittivity is epsilon r. If it is found that the angle theta remains same, then they are asking what is the relative permittivity. Here, just consider that this mass is same. This mass is same both. So let me just do, because if theta is same, then mass must be same, right? We remember the conclusion. If masses are different, then only this angle made by both the string differs. So let's say the particles density of particles is sigma. Let's take it sigma. Okay, and volume is v, and we know that total mass of this particle will be v into sigma. Sigma is the density of this particle. Now let me just uh, draw the FBD. Let's draw all the forces which are acting on it. Now here one force is tension, right? This is tension, and here we know that when by Coulomb's law in medium, you must know that when two charges are placed in vacuum, suppose if they are repelling each other with the force F naught, let's say F naught or Fe, and if they are placed in medium now, if they are placed in medium now, this Q1 and Q2 are placed in medium having let's say dielectric constant K or relative permittivity epsilon r, then we must know that the net force of repulsion between these two particles becomes Fe by epsilon r. Here also the force of repulsion will become Fe by epsilon r. So what is Fe? Fe is the force of repulsion between these two charges Q1 and Q2 when they are placed at same distance in vacuum. If now we have placed these both charges in a medium. A medium is sufficiently large, right? Medium is infinitely large. So if we placed these two charged particle in medium having relative permittivity as epsilon r, then you must remember that the net force acting on the particle decreases. Here let me tell you one more point, that force that Q1 applies on Q2 does not change. It remains Fe only. But net force decreases is because the medium here gets polarized. This is the different concept. Medium gets polarized, and medium also applies some force, and due to that, net force decreases and decreases by epsilon r. You know that epsilon r is always greater than 1. So yes, net force will decrease. Okay. So now I am going to put the value here that will be Fe by epsilon r. Now the force has become Fe by epsilon r, and mg is still acting. Now let me write mg also, and now as it is immersed in these balls, these particles are now immersed in um, are immersed in a liquid, then obviously here buoyancy force is also acting, that is V into rho into g. This is buoyancy force, and mg is there. We know that m is V into sigma into g, and this force is also there, and this tension is also there. So these are four forces here. Now what I am going to do, I am going to take resultant of these two first. I will solve this two, and I will try to see this situation in the same way as we solve this question in vacuum. So here is Fe, here is tension, and we know that here we had V into rho into G, and here we had V into sigma into G. So I will subtract these two equations. So we will get V into rho minus sigma into G, right? I just did mg minus Fb. Here mg is V into sigma into G, and in upward direction we had V into rho into G. So we just subtracted. Net force will be let's say downward. So this is the force and this is tension. Again they are saying that net force remains the same. Okay, that means still this resultant of this two term is still at an angle theta, and I will write tan theta is equal to Fe by epsilon r upon V into rho minus sigma into G. Now you know that here where I wrote mg, let me write V sigma into G. And now just come, because as these angles are same, just equate it. And if we equate this Fe divided by V sigma into G, we will get the answer. And we are getting this sigma upon rho minus sigma. This is it. So this is how this questions are solved. Obviously for NEET, uh, this is the among the hard, tough questions category. Okay, but it's not really that tough if you know how to solve it. But at least you must try. These are the toughest questions that can be asked in NEET, and even in JEE mains. This type of questions can be labeled as medium to hard. And now the last question. This is really a simple question, tricky question, but I have seen at least 80 to 90% students, even the number can be greater. 80 more than 80% students remains confused in this question, because they think the theory is really simple, or at that time they don't understand the depth of the theory. Like, it is simply based on Coulomb's law. What is it is saying that a charge q1 exert force upon another charge q2 placed at some separation, and force it exert is F. Obviously, then Q2 will also exert same force on F. Okay, that's not a problem. Now, if a third charge Q3 is brought here, now it is quite placed close to Q2. Okay, close to Q2, it doesn't matter. Close to point charge. Remember, point charge. Q2 here. Now, what they are asking, then the force that a charge Q1 exerts on charge Q2, force that charge Q1 exerts on charge Q2 will be. So what will happen? Will it be F less than F or greater than F, or what? So most of the students, sometimes, because they get confused, and then after that, what you do after getting confused. So when Q3 was not there, Q1 is applying force F on Q2, and now they are asking what force Q1 will apply when this charge is present here. Let me just recall what is Coulomb's law, and you will get the answer. Coulomb's law states that, let me just remove this because we will get. Coulomb's law states that two charge, 2 point charge. Firstly, Coulomb's law is valid for point charges only, and here we are talking about point charges, so we don't need to think anything else apart from the statement of the Coulomb's law. Coulomb's law states that the force of attraction or repulsion between these two charges will be equal to 1 by 4 pi epsilon naught q1 q2 upon r square, and this is r. Now, okay, now this force F, you just see, you just tell me that on which quantities this force F is depending. It depends on Q1, it depends on Q2, it depends on, sorry, this is R square. I wrote it here, R2, this is R square. Okay, so and here this is constant epsilon naught. This is a universal constant epsilon naught. This value of constant does not change, right? This is a universal constant. uh, like G also, gravitational constant. So this is not going to change in any medium. This is same. Now Q1, Q2, and R square. Where is Q3? Are you seeing any? Are you seeing Q3 here in this formula? This is Coulomb's law. You know, this is Coulomb's law. So Coulomb's, if you accept what Coulomb's law is telling us, then you must not have any doubt and say that answer will be F. That it doesn't matter if Q3 comes or Q4 comes or Q5 comes or 1,000 charges comes, the force that Q1 exerts on Q2 will remain same, and that will be F. So, okay, students, you got it, I think. So these were some questions, which I think, if you are able to solve all these questions, and if you know what we did in each steps, and if you understood everything, then I think your electrostatics is good, and your command over this topic is going to be very good. So okay, students, I will come up with again such 5 questions from some other topics, and hopefully you will get benefit uh, in that video also, and I hope you have learned something in this video, has been really beneficial for you. Okay, students.